Hey everybody, it's Matt from Eastwood Company. We're here at another live tech session in the Eastwood garage. If you've never watched one of these before, we want it to be as interactive as possible. So we want you guys to log in, jump on our chat. Over here we have Scott, who's one of our technical advisors. He's going to be answering any of your questions you may have immediately about what we're doing today or welding in general. He can answer them. He's also going to save some of your questions and put them to the side and ask them of me throughout the broadcast. So I'm happy to answer questions live, and I'll do my best to answer them as completely as I can. So what we're covering today, we've done a bunch of TIG welding videos in the past on these lives, doing the intro to TIG welding, show you guys how to set up the machine, initiate an arc, how to hold your hand. I gave a little bit of demo on feeding rod. What we're getting into today, we're going to skip past all the intro stuff. We're going to get into puddle control, a little bit into how to make sure that your puddle stays where it needs to be, and making sure if you're working on something that's an edge that's delicate, how you can keep your puddle real nice and tight so that you're not harming areas around it to make a nice, small, clean weld. So we're going to be doing most of the work right here in the table. Over the machine I'm using today is the Eastwood TIG 200 AC/DC machine. This machine, of course, does aluminum and steel. We're running 100% argon, which I'm going to make sure I have open here. And the machine, I'll flip it on here. I'm running it with a pedal control. And we'll switch it back to DC here. We're going to start on steel, on DC. Now, if you haven't watched one of these before, what we like to do is try and get you guys what it's like under the hood. So we have a camera that we have a lens we put on over it so you guys can see exactly what we're welding. So bear with us. It might take a few seconds as we put the lens on and we get focused. But we're going to get in and try and get that shot. And I'm going to talk as I weld so you guys can see exactly what's happening. So the first thing, while we get right into it, is the tungsten or the electrode. If we're doing something that's really delicate, today I have a 1/16 electrode in, which for the metal that we're welding, which is 1/8 inch, is getting towards the higher end of what this electrode can do. You can weld like 1/4 inch, but you got to be careful. But I like to use that smaller electrode because it allows you to get a smaller puddle, smaller arc. The other thing I have, this is a 3/32 here, but I already have one ground, so I don't have to take it out of the torch. I have this ground to a real fine point. So I pretty much sharpened this enough that it would poke into you. But this is sharpened basically to a point because I want that arc to be a puddle and the arc to be directed as tight as possible. Get it right into the seam where we're welding, so I can control that puddle and it's real small. Now, if you're welding something that's a larger area where you want to fill something or you want a larger puddle, you can basically take this tip and put it on the grinder after you sharpen it and flatten the end. What that'll do is that'll open up the arc and give you a wider puddle that you can weld with. But today, we're trying to keep that arc nice and tight. We're going to try and keep our puddle real small so we can keep from burning away the edge too much when we're welding on something. So that's the setup with that. The other thing I have here is I have a gas lens. I have a kit sitting here on the table as well, but I have one of our gas lenses hooked to it. This is highly suggested for TIG welding because this is going to give you better gas coverage, especially when we're welding something that's this delicate. We really want it to be good gas coverage. We don't want any type of contaminants getting in the weld because on these little tiny welds it could really cause a problem by getting contaminants in there. So gas lens kit is really good. I got the gas lens with the 1/16 accessories inside to match our electrode as well. So I'm going to sit down here. Again, we got our bottle turned on already. And let's get comfortable. So we're going to start with a T-joint here. And a problem I often, when we do classes and we speak with beginners a lot of time, a problem that they seem to have is when they're welding a T-joint or a lap joint, they have problems with directing their arc and getting into the center and keeping the puddle kind of centered on what they're welding. So I want to show you guys that and a couple little tricks, and maybe it'll hopefully get you started so you don't have as many problems. So we're going to jump in with the lens. I'm going to get set up here as he's getting comfortable. And I'm also using 1/16 filler rod. So just bear with us for a second while we get set up. And now I'm checking my distance from the workpiece here just to make sure that I'm happy with where I'm at.
Good?
All right. Yep. So I'm going to try and keep my helmet back a little bit so we can get the camera in there. So I'm a little out of position here, but we're going to start. So what I do is I start the arc there, and I'm kind of aiming the arc right there in the center of the seam. And it's okay to let it kind of heat up and get hot to start that arc. And I'm giving a little more pedal, and once I see it start to connect there, I'm going to put a little dab in, and I'm keeping that filler. I'm putting the filler right in the seam. So you don't want to put the filler high or low. We're just trying to fill that seam in the center and keep our edge nice and tight. And I have the puddle, keep the puddle centered right over that seam. But as you can see, I'm adding the filler right into the edge, the center of that seam and the edge of our puddle. I'm going nice and slow so you guys can see what's going on. Again, I'm out of position a little bit here so I don't bump the camera. This end section here. So there where you turn the torch, when you turn your torch up like that, that's what causes it. So try and keep your hand centered, or your even your fingers locked in the same position. So same thing can happen. We drop down just a little bit. See how our puddle got below? You raise it back up. That's what can cause the control issues here. And the same thing can happen if you turn your torch like this, where we're getting too much of a torch angle. See how our puddle opens up, and now we're hitting a much larger area. So if we're trying not to harm anything on either side, it's going to cause a problem. So get yourself relocated. And drop our puddle, our dabs right into that crevice there, into the valley. We're getting towards the end there. One more dab in. Let off. So we're going to show you guys the piece here before I do another one, and kind of just diagnose exactly what was going on there when I was turning my wrist so you guys could see. So let's see if I can grab this so you guys can see. Actually, let's start like this if you can get in. So you can see here in the beginning when I started, before we started turning our wrist and changing, nice, pretty consistent puddle there. Overlaps real nice. The puddle's nice and small through here. And then right in here is where I started turning my wrist as I was talking to show you guys. You can see the puddle starts to go up towards the top of the piece. And then in here is where I turned it so it went down to the bottom. So you can see we're starting to cut into the bottom a little bit. And then in here is where, I'll actually use a piece of filler rod to keep my fingers out of the piece. So in here, actually in here basically, is where I turned the torch. So we had too much torch angle. And you can see it really opened up, and now we're hitting, you know, our puddle size almost doubled in this section where we turned our angle. So all it took was just that little bit, and suddenly we're eating away at either side of this. So if you're doing something that's really delicate, that could cause you some extra work that you're going to have to fill on either side. Then I went back in to pull it tighter, added our dabs real quick until we got to the end and we connected with the little tack weld I put on the beginning. The other thing to look at is looking down the piece. You can see how the weld starts coming out in those sections where I was opening up the torch. You can see that, but in the beginning there it's nice and tight. Everything's kind of in line when you're looking at it. So just that little bit, but you want to aim right in the center of that when you're doing that weld. So that's a first one, doing a T-joint on steel. Scott, do we have any questions that came in for TIG welding yet?
Right now, one of the guys asked if you could talk about pulling or drawing the weld.
We can, when we get into the aluminum, we could probably show a little bit of that. If I'm understanding his question correct, it'll probably show up on aluminum a little better. So now we got this lap joint here. I'm going to show you another one on. And this is a great one to practice your edge control. Because you got this defined edge on the top here. So if we're trying to put let's hope that this doesn't pull some contaminants, but I'm going to put a little line pretty close to the edge here. So I put a line here that's maybe about an 1/8 inch, maybe a tiny bit more from our edge of our piece. So this is from the top. So we're going to try and keep away from getting any weld on that top edge there. I didn't want to go too much closer with the marker, but that's also, we can also use this top edge here to kind of help us as a defining edge. But we're going to try and glue the two of these together. By glue, I mean weld, of course. So what I'm going to do here, again, I'm getting comfortable, and I got to turn it at a funny angle. Normally I would run along the edge of the table with my hand, but we want you guys to be able to see exactly what's going on. So I'm going to actually pull this electrode in just a little bit. Since we're doing a lap joint, I don't need quite as much stick out as it did in that T-joint that we were doing there. Okay, so again, I'm going to favor the bottom here because I want to try and keep away from that top edge. So we're favoring that bottom. So instead of aiming right for the center, we're actually putting more heat into the base piece than the part that's overlapped. And I'm just adding little dabs as I go. So you can see that real defined edge. Hopefully you guys can see that for the top. We're trying to keep away from eating that sucker away. Now as you put more heat into the piece, you're going to have to start speeding up because you're starting to eat away that top layer a little more because it's getting hot. You can see them speeding up there. And just keeping those dabs actually below the seam so that when you add it, it's keeping away from that edge. Now a little out of position here, but we should be able to finish this. Let's dab up, let off, and we're done. That one is pretty kick-ass. With being out of position, got that going pretty good. So, let me grab my pliers here so I'm not burning my hands. So, that marker I put on there was absolutely worthless. All it did was when we put heat into the piece, it burned my marker off. But we could see that top edge right that we didn't want to harm right here. I mean, it's almost dead straight. Right here in the end, we have a tiny bit of undercut erosion here. Very, very little, but the majority of this piece here, we haven't even touched this top straight edge. And that little bit in there was just at the end there where my arm was kind of out of position a little bit, but for anything I'm doing, I'll let that slide. But we're going to try and get a nice tight shot there so you guys can see first the top edge, how we can see that it's not eating away. And just takes a second because we're going from a really dark lens to back to a normal, so it just takes a few seconds. So you can see that edge right here along the top where we're pretty much straight. I mean, we didn't touch it at all. We're down in the bottom. So like I said, I was adding my filler. I was favoring this base piece a little more, but when you added it in, it would actually pull up into our top layer here and put the two of them together. Now the other thing, you got that pretty good? So we're getting a little bit closer so you guys can see that straight edge along the top there, that top layer. So you have to aim your arc or your puddle favoring this bottom piece. I would say maybe half the distance of the arc where the puddle. We're favoring this side onto our base piece. And then we're adding our filler, into that same area. And when it does that, it actually fills up into our piece and as we go around. So right here at the very end, had a little bit extra heat into it, and because we had a tack in here, I had to put a little more heat into it to add some. So it has a little bit of an undercut there, I guess you could say, or it's got a little warm. But overall, we got a pretty darn straight edge there. The piece, you can look at the weld here and see. I'm going to try and turn it so you guys can see how it's curved into our piece there. So when you're looking down it, you want that. You also want this line on the bottom here where the other edge of your weld is. You want that to be pretty flat too, or I mean pretty straight along as you're going. But you can probably hopefully see in there how that's filling into that piece. Now what we could do if we had to come back, add an additional pass, we could fill in this valley here some more depending on what you're doing. You may have to do another pass, and the same thing, we're just adding on top of that real careful, and we could still keep away from that edge. Any questions so far, Scott?
There's one that's on here was if you could go into a little detail maybe at some point on welding thin sheet metal, any tips or tricks you have. And then someone else asked if maybe you could talk about walking the cup if you have time.
Okay. So the first question we had was about tips and tricks with welding sheet metal. I definitely am going to do a demo on doing sheet metal welding. A lot of what I like to do with TIG welding is sheet metal welding, doing patch panels and things. I'm going to try and hold off on doing the demo for that until we're actually working on a piece. If you look back at some of our videos, we've done some TIG welding on sheet metal. I made a transmission tunnel for my Model A, and we showed welding some of that up. But I'll get into doing a little demo that gets a little more in depth here in the coming months, I'd say. But the biggest tips I can get for the short of that answer are you want to sharpen your electrode to a fine point. So you get a real small tight arc. You want your amperage to be low. You want your piece to be as close as possible, or you want your work pieces where you're butt welding or whatever to be as tight of a joint as possible. And you want to use filler material that matches what you're welding as best as possible. So if you're welding like 030, if you're welding like 18 gauge, you can use like an 030 or 035 wire. That's pretty close to the same thickness. But the filler material that you pick is really important. That's a big mistake I see, is that people are using 1/16 rod and they're trying to weld together 18 gauge steel or 20 gauge, where your rod is thicker than your material that you're welding. Therefore, it causes you have to put more heat into it to melt your filler material than you do your base material, and blows holes in it. Not good. So that's the short answer to that. We will definitely do a demo on that here coming soon. Walking the cup, I'm going to admit that that is a weakness of mine. I am not very good at walking the cup, probably because I don't really have much experience in doing it. So I'm not really that confident in doing it. Only thing I could say is just practice practice rolling your torch around like this over and over again. Like I said, I don't do a lot of that welding. I don't do a lot of tubing as much as I do sheet metal and fabrication on box tubing, stuff like that. So I'm definitely rusty on it. So I only want to give you guys the best experience I can, where it's something that I'm confident in doing, that you're going to learn something. So there is a bunch of really good videos out there, guys that do pipeline welding and things like that, that they show walking the cup. That probably would give a better explanation of it than I would, to be completely honest. But good questions for sure. So we got a couple pieces of aluminum here. I'm going to do, so we're not making this too long here, I'm going to do one more doing aluminum. I'm going to do a T-joint. This is something that I see people that are beginning with TIG welding, aluminum especially, they struggle with. Similar process, and somebody asked earlier about pulling the weld. I think you can see it pretty good on aluminum. So we're going to flip over to the AC side here. The one thing, because we're talking about puddle control here, what you really need to do with your settings is on your clearance effect. On our machine, it's called the clearance effect. On other machines, some other machines, they call it AC balance control. You want it to be more to the negative side. I go pretty far to the negative when I want to really keep my arc nice and tight. All this means is that we have a smaller, tighter arc, but it doesn't clean as big of an area. So you have to make sure that our workpiece is cleaned really well to make up for that. But the more negative you go, the smaller and tighter your arc's going to be, but the less cleaning you're going to get. So you have to keep that in mind. You have to balance the two. So I'm using the same tungsten electrode. We have the E3, the purple band electrode that we're using. The nice thing about this is we can jump right over to the AC side, flip a switch. This will weld just fine. We don't have to do anything to set the tip or anything like that. And it's nice and stable. I'm going to turn our gas up just a little bit since we're doing some aluminum here. And we'll show you doing this T-joint. And I'll show you about getting your puddle control and getting started on a joint with aluminum. So we're going to jump back over and we'll get one more with the lens. And then if you have any additional questions you want to ask, drop them to Scott, and either him or myself will answer them. If you have any ideas for future broadcasts you'd like to see, like somebody asked about the sheet metal TIG welding, which is a great one, we do have on our list here coming up soon. But if you have any other ideas for painting, welding, anything like that, drop a comment. We'll definitely we're getting a list going because we like doing these. We want to keep it going. Oh.
While you're setting up, Matt, one of the questions that came through, I think would be a good one while you're up there.
Sure.
Ask what the benefit between TIG or MIG on sheet metal.
Okay, so somebody asked a great question we get from time to time. What is better, TIG or MIG on sheet metal, correct? That was it? Yeah, so what's better for TIG or MIG for sheet metal? It depends on your skill level, to be completely honest. So if you're comfortable with MIG, definitely use it, but TIG welding overall is better It's a softer weld. You can actually hammer and planish the weld, where with MIG weld it tends to get brittle and will crack when you hammer on it when you're welding or want to move the metal around. It's not quite as forgiving. The weld's also harder to grind, so you put more heat into it when you're sanding the weld away. So I prefer TIG welding, but it does have a steep learning curve that you need to practice a lot to get your joint preparation correct and and get the technique of TIG welding down pretty correct. Good one. So we're going to get back into position. Thanks for the questions. Again, drop them in and we'll answer them at the end. Then we're going to answer a couple questions if we have any. All right, so we'll start our weld and we're going to let it clean. Now what I like to do is as soon as I start seeing it start to get a puddle, and I like to smash the throttle and put a dab of filler in. Once you get that filler going on the top to the bottom, you can start adding it to your workpiece. Now you want to pump the pedal, keep it real steady. So I'm actually adding this one more to the base piece than the vertical piece, because it kind of overlaps the way the aluminum pulls it in, the weld. I'm kind of adding it more to the flat here, you can see. So I'm actually dropping it right on the flat there and hitting the pedal. That's when you can hear the intensity go up. That's our pulse. So we're dropping it right on the flat piece. I'm letting it kind of suck into the puddle, roll it in, and it's going up to our top piece, and we're getting a nice consistent weld. So I'm going to add a little bit at the end here, back off slowly, let our post flow come out, and we got our quick little weld here. So you can see on that versus the steel where we were trying to put it right into the seam, I was kind of dropping it into just below the seam on the flat, which allowed it to kind of pull into the weld, and it filled up that seam that we were welding and melted everything together. So when I hit that pedal to give it a bunch of amperage, it sucks in my filler rod, puts it into the puddle, and it melts the two pieces of metal together at the same time I'm adding filler material to it, and joins all three of them together. Ooh boy. All right. So you can see our welds pretty consistent. We've got a little spot there. I probably added a little too much filler into it, but you can see that we're not going real high into the piece here. We're not eating away. We've got a nice consistent flow of the weld. But so there's small little differences by turning your hand or putting the material, the arc or the filler material just a little below the seam. Those small little differences will make a big difference when you're welding a seam that's a joint like this with aluminum versus if you were doing steel. So you can play with it a little bit, but I like the big trick is when you get started to add that one nice dab of filler into your the first part of when you're first starting your puddle, and that kind of gets you going, that jump starts you. And once you get that nice little puddle going, then you start dragging it from there and adding your filler rod. If you try to sit there and heat it up and get the two of them to melt together before you add your filler, that's where you start to get problems where you overheat the workpiece, you start blowing holes into it, and you can cause those problems that we see with aluminum for beginners when you're doing a joint such as this. So hopefully that gives you a little bit of information about puddle control and some things you can do to keep your puddles nice and tight. If you're working on something where you don't want to damage an area around it, take some of these tips. Hopefully they'll help you and get you guys doing better welds. Any questions?
One last good one is Thomas asked, you know, it's obviously different than a MIG welder. You know, are there any obvious signs or sounds to know when you have it tuned properly?
I will say, so the question was, Thomas asked, is it like with MIG welding, is there any sounds that will kind of tell you with TIG welding that you have the machine set up properly? I'll say on aluminum, there is. When you have a nice clean arc or puddle going in aluminum and the metal's nice and clean, you'll just hear a consistent kind of buzzing sound. And if you listen on the video, you can hear it, that buzzing sound. The intensity went up and down. That was me pumping the pedal, giving it more and less amperage. But otherwise, you shouldn't hear like a sound like you're getting an arc that's jumping, that's inconsistent, where it's bouncing back and forth. That's where you might have something, you don't have a good ground, your piece isn't cleaned well enough. If you start hearing it kind of buzzing and jumping around, that's the one sound you can hear that you're not correct with aluminum. Steel really doesn't make any sound when you're TIG welding. It's mostly just the sound of the gas coming out. So you can't really listen as well with TIG welding on steel to know that your machine's set up properly. But the nice thing with TIG welding is you can see everything that's going on. So MIG welding, it's a little more difficult sometimes, especially if you're doing spot welds or stitch welds. It happens so fast you can't really see the puddle. Your brain can't function what's happening quick enough to make any of those changes. With a TIG welder, you have a pedal and you can see the puddle, and I can tell if my puddle's not large enough or if I need more heat, I give it more pedal. So you can actually do it on demand, which is nice. So TIG welding, you really got to watch your puddle more than listening. You need to use your eyes more so on these. But that is a good question. That's one I haven't had before. Any other? Cool. Well, thanks everybody for watching another live demonstration. If you guys have any ideas, like we mentioned before, make sure you drop them in the comments. We'll try and do some live technical demonstrations that you guys suggest, so you guys are watching what you want to see. Thanks for watching. I'm Matt. I'll catch you guys later.